So the topic of this chapter is presenting the results. And so there are many issues that the performance analysis people have to know. And this is final thing. Basically, if you do it wrong, then your analysis will have no impact. So it's important to present it correctly. So in this chapter, we'll talk about what are different types of variables, how do you plot charts, how to avoid common mistakes, and what are the things that people do to make their thing look better. So first of all, variables. Variables could be quantitative or qualitative. If it is quantitative, it could be discrete or continuous. It could be integer or floating point kind of thing, right? Discrete or continuous. Continuous is floating point, discrete is integer. Qualitative could be ordered or could be unordered. So let's see. Type of computer. Suppose you want to decide between supercomputer, mini computer, microcomputer. Which kind of variable is this? Is it quantitative or qualitative? Qualitative, right? Okay, good. And if it is qualitative, is it ordered or unordered? Yeah, this is ordered because microcomputer is generally smaller than mini and smaller than super. And so on and so forth. Type of workload, and you could have similar example where there is not ordered. For example, you could have disks of two different types, SATA, SATA or IDE, something like that. Okay, then you have the type of workload. Scientific, engineering, and educational. There are three workloads. Is this variable quantitative or qualitative? Qualitative. Is it ordered? It's not ordered. So this is this branch. Number of processors in a system is quantitative, discrete or continuous? Discrete, because you cannot have 3.5 processors. Okay, so this is discrete, third box. And fourth is the response time of the system. Is quantitative, continuous. Now the reason we need to know these four different variables, four different kinds, is because the way you plot them is different. We will talk about that in a minute, but before we do that, guidelines for preparing good charts. And so the key goal of any presentation is to minimize the effort of the audience. Same goal I have it. I want to minimize the effort for you to get some idea of whatever idea I want to transmit. I get the concept. And so with minimum, so basically that's the presentation. Same thing when you present to your bosses, you have to present it so that they benefit from it. Require the minimum effort from the reader. When you write a paper, your goal is so that people can read it like this, fast. Why? If they can read it fast, a lot more people will read it. If you require 1 hour to read it, then a lot less people will read it. Based upon that metric, tell me this one. If I have a graph where I put A, B, C right on the graph, as opposed to I put a chart, legend box, which one requires less time? Left one, right? However, Excel doesn't produce that. What does Excel produce? The right one. So 99% of the graphs you read in the papers are the right kind. Okay? And if you can, please take the time to prepare the chart from the Excel, but then dismantle it and put the labels where they belong. You can do that. And you can take an Excel chart and say, what is the command? Ungroup. Right? And you can delete the legend box and put ABC right where it belongs. Most people don't do that because there is more time on the writer, less time on the reader. Basically, so they just try to minimize their time. If the names are, a paragraph, obviously you're not going to put it into the picture. Right? Then you will put the paragraphs A, B, C and then put the labels here. Again, you have to trade off the legibility and the convenience, everything else, right? So, of course, you have to use common sense. On the other hand, if it is a very long name, this doesn't help either. Legend doesn't help either, right? The problem with the legend is that I have to really match the lines variety. and sometimes if there are more than 3 lines, you can't even distinguish between the lines. So maximize, first goal is to require the minimum effort. Remember, that is the goal. Second goal is to maximize the information. So you really want to put as much information as possible. So instead of putting A, B, C, what you should really be putting is the words. Dell PC, HP PC, IBM PC. Just put the words right there. Because now they don't have to go back to some place and say what is ABC. See, there is an indirection here. First of all, there is an indirection here is that first I look at this type of the line and then I go to this box to find out, and then I go from here ABC to figure out what A is. 2 indirections. With this one, at least one indirection is avoided, but I still have to find out what A is. Why not put A right there and then people can get it right there? So clearly label the axis. So what I see is a lot of times when people write papers, they will write lambda and mu and R. Right now I don't know what R is, what lambda is, what mu is. So I have to go and read the paper maybe 3 pages before they described it. Right? That is how you are penalizing the reader. Okay? So why not put just the number of users, R is response time and number of users is N, and so on and so forth. So that is, so put the words that people can understand right away. Then third goal is to minimize the ink. Ink is expensive, because you have to buy it, but that's not the reason. The reason ink is expensive is because every ink has to be processed by the brain. So this is in some sense related to the first goal, minimize the reader's time, is that whatever is on the screen, whatever is the ink here, that has to be processed by the brain to figure out why it is there. So no grid lines, more details. So what happens is, Excel, if you don't do anything, it will produce a grid lines, all that. And are they helping, are they hurting? There are situations in which you need the grid lines, and there are situations you don't need the grid lines. Okay? There are situations where people have to read exactly this is 7.5. Other places they don't need to know exactly 7.5, they just need to know that this is better than that one and this looks like twice as much. And so 7.5 you can just write there, but you don't have to have a grid line to be measuring that thing. So you have to think about that different situations. So the grid lines are examples. The grid lines do add the ink, but may not add any information. And then when you have grid lines, you have to decide how many grid lines, because you could have every millimeter a line and then you will have 50 by 50 chart. And you could have just 5 of them, right? And so that is, the thing is, no grid lines, more details. So basically the idea is that you have to argue as to, you have to process the chart after it comes out of Excel. By the way, in our days we didn't have Excel, so we had to do this processing anyway. But nowadays, even I use only Excel for all the graphs. So I have to process it every time I use Excel. Alright, second thing is use commonly accepted practices. So most people expect that the origin is 0, 0. Now you can buy it. Again, this is art and science business. There is no reason I can give you a rule that, you should never use non-zero origin. But you should use 0 origin if possible. If there is a reason for you to use non-zero origin, then, you clearly indicate that this is non-zero. For example, these 2 graphs are same. This one shows availability and this one shows unavailability. Obviously, I think if you really wanted to give the information is hidden here, where it is clear here. And so that is the thing, is that with minimum ink you can give maximum information. And then the thing is, then independent variables. Second thing is x and y axis. X, I'm coming to you in a minute. X axis is independent variable. Remember that. X axis is independent variable, y is the dependent variable. A lot of people don't realize that, and they will have something here which they cannot control. Just the opposite. So here, days of the week is the independent variable that I can control. I can say Monday, Tuesday, Wednesday. And on Monday the availability is this. That I cannot control. So that is the output. So you have to put the independent on the x. X is independent and y is the dependent one. Well, I mean, you could go either one. Remember, there are 3 principles we have done so far. One is minimize the reader's time. second is the maximize the information, and third is minimize the ink. Now, if you don't buy that it doesn't minimize the ink, probably it uses the same amount of ink, but I think it maximizes the information. It clearly brings out the differences between the systems. Okay, so it does, then you are happy with the third one. Okay. People assume that the x-axis is along the in linear scales, and most people expect in linear scale. Now, sometimes you have to use log scale, so I'm not saying that you ban the log scale. But common term is that unless there is a reason for you just go for log, linear, and if there is a reason for log, then you explain that, well, this thing has to be shown at log. And we will go through lots of such examples in our actually studies. Increasing scale, and generally we want to show increasing scale. I have seen people showing the decreasing scale. Equal division, we generally expect things to be equal as opposed to non-equal. So there are exceptions to this. Any places we have seen, and we could go on the examples, but I'm not going to go there right now. Avoid ambiguity. Show coordinate axis, scale divisions, origins, identify individual curves and bars. So, for example, here. Make sure that the scales are there. I have seen graphs where there is no scale. Scale is missing. Divisions are missing, and the curves are not identified. Here things are identified because it says 1, 2, 3, 4, 5. So there is a whole checklist in the book, box 10.1, which you can read. So the whole set of things which talk about how to present. Now this is something that they teach in high school, I know that, but most people forget by the time they write papers in graduate school. So I just need to remind you that this is how you do the plotting. Now let's see some more common mistakes. So presenting too many alternatives on a single chart. So because the papers generally have the limit of 5 pages, 6 pages, 10 pages, 2 graphs, whatever that is limit is, we try to cram the information into one. So this graph shows throughput, utilization, response time all in one graph. For throughput you measure, the scale is here. For utilization, the scale is here. Sorry, throughput, the scale is here. This is the response time scale, and this is the utilization scale. I am already confused. Right? And so is the reader. They can't figure out where to read what. And so this is the kind of thing which is done very often is in the papers, particularly not in the books, because in the books we have time, space, but in papers there is shortage of space. So try to minimize that. I mean, if it was really important, then maybe do 3 graphs, or at least so be clear about this. Anyway, using symbols in place of text, and this is very common in technical papers. That R versus lambda for mu equal to 1, 2, and 3. And what is R? What is lambda? What is mu? We don't know. That you have to read in the paper. All right, and sometimes people forget to even explain that because they use R, lambda, mu so often. They forget to write it in the paper. So why not just say arrival rate versus response time versus 1 joules per second, for 2 joules per second, 3 joules per second, and so on. And then placing extraneous information on the chart. So grid lines and granular, those things are information that may not need. For example, if you have this graph that clearly says some information and that is sufficient, and putting grid lines will hide that information. Select scale and ranges improperly. Automatic selection by programs may not be appropriate. So you really have to have the right minimum value, maximum value. So in the Excel allows you all this flexibility, but people don't go and use it. When you give it to Excel data to plot, it automatically selects the minimum, maximum, but you can go and change anything. You can change the axis, you can change the graphs, you can change the labeling, and so on and so forth. Okay, another final mistake, and then we'll stop, is the line chart in place of column chart. So now, CPU type is what kind of variable? Qualitative. And basically, so for qualitative variables, you cannot use continuous chart like this, because this one says that 8000 has this performance and 8100 has this performance, and if you had 8050, which I don't know is there or not, you will have this performance, which is not true, right? So you really need only 4 points to show and not these lines which are connecting intermediate points which are not there, right? And so this line should not be there. Basically what we should have is actually a column chart, which means a bar chart more like this, where you will have one CPU, second CPU, third CPU, fourth CPU, 4 points.